Hey everybody, I'm back. Okay, so we're finishing up page 4. Let's check this out. So we're doing confidence intervals, and this one is when we have sigma, which is the population standard deviation. Okay, so let's see what we have here. A college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, okay, oh, see that I have this on there. Okay, lags so much for me. The mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years. Okay, that would, and the population is normally distributed. So they're talking about the population there. Construct a 90% confidence interval of the population mean average. Okay, so let's go through and see what this problem's giving us so far. So they're giving us a random sample, so n is 20. The mean age, so x bar is 22.9. And then that standard deviation is the population standard deviation, that's 1.5. Okay, so now let's get into our checklist here. So the first thing on our checklist is, do we have sigma? Well, yeah, we do. Sigma is 1.5. Okay, so that's good. The next one is, do we have a simple random sample? Well, they're saying in a random sample of 20 students, so yes, we do. And then the last thing is we have to know if the central limit theorem applies. So in order for that to happen, n has to be greater than or equal to 30, which it is 20, so that doesn't work. Or the population can be normally distributed. Right there. So that does work. We do have the central limit theorem applying there. Okay, so now from here, we are going to find the margin of error, which is E. Okay, so E equals C sub C times sigma over the square root of n. Okay, so we have sigma 1.5, and then the square root of 20, we do have n, but we do not know z sub c. So we have to find that. So if we have confidence level 90% or 0.90, what that's saying is that the area in between two z-scores, which they're the same z-score except just different signs. So one's negative and one's positive. Okay, the area in between those, ooh, did I do highlighter or did I do magic pen? I did, oh, text pen. Huh. I keep saying it's magic pen. Okay, so the area here is going to be the 0.90. Okay, so the reason why we're doing this is because the last area that we found was 0.95, so this is a new one. So this is 0.90, which means we need to find this leftover area in order to find that z-score. So I'm going to do 1 minus 0.9, which is 0.1, divide it by 2, because there's 2 of those areas, and I get 0.0500. Okay, let's look in our z table to find that area there. Let's see, 0.0500. Oh, I already have it underlined for us. Okay, so look at it's right here, but it's right in between them. Right, it's not any closer to 0.0505 as it is to 0.0495. Okay, it's actually right in between. So what that tells me, so negative 1.64, negative 1.65. So what that tells me is for, I'm gonna move me up here, the C value of 90%, that has a Z value, a critical Z value of 1.645 because it's directly in between those two. Okay, so that's the Z-score that we're going with. And we're plugging it in. Okay, so I got 1.645. Okay, and we plug that into our calculator, and what did I get there? I got that E is approximately 0.6. Okay, so I am going to, so let's kind of label these steps. This is step 1. I guess this can be step 2, really. I guess I should have found that first. And then we finish plugging it in for step 3. So then step 4, now we're plugging it all into the formula, which is x bar minus E is less than mu, which is less than x bar plus E. Okay, so x bar we have as 22.9 minus 0.6, which is less than mu, which is less than 22.9 plus 0.6. Okay, and I get 22.3 less than mu, which is less than 23.5. And then the final step is just to interpret this. So I'm going to say with 90% confidence, you can say that mu age of students currently enrolled is between 22.3 and 23.5 years. Okay, there's my 5 steps for this. Not too shabby. Okay. So let's jump to page 5. So for the same sample statistics, as the level of confidence increases, the confidence interval widens. As the confidence interval widens, the precision of the estimate decreases. Okay, so how I kind of explain this is, think if you had a target. Okay, even think of like you went and played darts, okay? Like the whole area of the dartboard. Oh, that is terrible. I'm going to use my resources here. Okay. Okay, the whole area of the dartboard versus the bullseye. Okay. I'm definitely more confident hitting somewhere in here, and I'm less confident hitting the bullseye. Okay. But if I'm just saying, oh, I'm going to throw it and hit it somewhere on the dartboard, I know I can do that. Okay. My skills, my shooting precision is not that accurate. Where if I'm hitting the bullseye, that's a lot more precise. That's a lot more accurate. So that's what this is saying up here is if you are more confident, so let's say I'm like 99% confident that I'm going to hit in here and maybe only like 80% confident that I'm going to hit in here, right? If I hit in the 80%, that's a better throw, right? So one way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. So we are going to find a minimum sample size to estimate mu. So given a C, which is a level of confidence, and an E, which is a margin of error, minimum sample size, N, needed to estimate the population mean mu is, we're going to use this formula, N equals the critical z-score times the population standard deviation divided by the margin of error squared. Nice. It's just a plug and chug. Okay, so the economics researcher in example 1 wants to estimate the mean number of hours worked by all grocery store employees in the county. So we're trying to figure out how many employees must be included in the sample to be 95% confident that the sample mean is within 1.5 hours of the population mean. Okay, so what we're given here is that C is 0.95, and then since that's 0.95, I think we already have that z-score. I think the only one we don't have is 0.99. So yep, it's 1.96. Equals 1.96. And then this is from example 1, which I think comes from example 2 and example 3. Okay, so actually, so from example 2, we get that the population standard deviation is 7.9 hours. We're going to use that. So sigma is 7.9, which is from example number 2. Okay, and the last part that we have here, the 1.5 hours, if it's within 1.5 hours of the population mean, that's the margin of error. Okay, so now it's just a plug and chug. We have n equals z sub c sigma over e. We're squaring this whole thing. So we have 1.96 times 7.9 all over 1.5. And then we're going to square this sucker. Okay, so you plug that all into your calculator and that you get n about 106.56. Now we're talking about a sample size. Okay, so we never want part of a person. No matter what, no matter if this is like a 0.0001, you always round up. Okay, because if you round down, you won't have enough people. So you always want to round up to the nearest whole number. So this is going to say the researcher needs at least 107 employees in the sample. Which means that they can have more than that, but as long as you have 107, then you should be good. Okay, cool. Now the only other thing that I'm going to do on here, just because we don't have it, is I am just going to find that last z-score for the 99%, just so that we have it. Okay. So for the 99%, that's saying that okay, from here to here, okay, all in here, that's like an area of 0.99. So we're going to do 1 minus 0.99, which is 0.01. Okay, there's 2 areas there, so divide it by 2, and we get 0.0050. Okay, if you go there, 0.005. Okay. So it's actually, I can see here, it's right in between those. So it's 2.575. So if the C is 99%, then Z sub C is 2.575. Okay, just so that we have it. Cool. So we're going to end the video there. We're going to start with the 6.2. Again, if you can watch these videos as soon as possible, just so that when you get the exam next week, you could work on it. And the sooner you finish the exam, the sooner you're done with this course. So that's why I'm trying to get it going here. Okay, so that's the end of this video. I hope you guys all have a beautiful day. Talk to you soon. Bye.